So guys, this is JEE Advanced 2026 paper 1 question number 2. It's a very good question from EMI beta. You can see in this question we have a two circuits actually, है In the first circuit we have a capacitor, inductor and a AC source. Inside the bigger coil we have a smaller coil which is connected to a ideal wire. Ideal wire means its resistance is actually 0. Okay, so let's start this question. They want resonating frequency, which is nothing but omega is equal to 1 upon under root LC. But we need to calculate L effective beta. C will be C. So let's start with calculating a self-inductance of the bigger coil. We know the formula of self-inductance is mu naught N square AL, correct? Now here N is number of turns per unit length, and according to question, N number of turns per unit length is capital N here. So if I fill this value, I'll get mu naught N square HD. Okay. Now again, for the smaller coil, it has a 2n number of turns and S by 2 area, 2n number of turns per unit length. So if I fill the value, L2 will be nothing but mu naught is mu naught, N square will be 2n square, and area is beta 2S, and area is S by 2, and length is D by 2. If I simplify this, I'll again get L. Okay. Now it's turn to calculate mutual inductance beta. Mutual inductance formula is flux through the secondary coil divided by current in the primary coil, right? That is M is equal to phi 2 by I1. Now I am taking primary coil as the bigger coil which is carrying current I1 beta. Okay, so it's an infinite long solenoid because they have mentioned D square is very greater than compared to S, right? So magnetic field formula is nothing but mu naught small ni. Small n was number of turns per unit length, which will become mu naught capital Ni1 here, right? Let's talk about number of turns in the smaller coil. So number of turns per unit length is 2n, and beta length of the coil is D by 2, and area of each coil is S by 2. So this is total area, and this is magnetic field divided by I1 will give us flux. If we simplify this, we'll get L by 2. Fine. So till here it is okay. We can calculate self-inductance as well as mutual inductance. Now second step is quite conceptual. First of all, if you see the secondary circuit beta, we have a coil, but we have a ideal wire which is resistance is infinite. So if the induced EMF is E2, then the current in the circuit will be E2 by infinite, E2 by 0 by the way. And E2 by 0 means current will be infinity, which is actually not possible, right? So what does it mean? It means EMF across the secondary coil has to be 0. And the EMF in the secondary coil will be due to two reasons. First of all, due to mutual inductance and due to self-inductance beta. So due to mutual inductance, it will be M di1 by dt, because current in the primary circuit is I1. So due to mutual inductance, it will be M di1 by dt. Similarly, due to self-inductance, it will be L2 di2 by d2, and of course they should oppose each other because we want 0 EMF. If I simplify this, M is nothing but L by 2 and di1 by dt, L2 is again L and di2 by dt. We can see that by this equation we can come to this logic that I2 will be nothing but I1 by 2, correct? Now let's go to the primary coil beta. In the primary coil we need to calculate induced EMF. So first will be due to self-inductance, and second will be due to mutual inductance. And of course we will have minus sign again here. So it will be L1. L1 is nothing but L, and di1 by dt is dy by dt, minus sign minus, and M value is L by 2, correct? And if I pull the value of I2 here, it will become di1 by 2 by dt. If I simplify this, I will get 3 by 4 di1 by dt, which is nothing but L effective di by dt, and here we can see L effective is nothing but 3L by 4. But what was the formula of omega naught? Omega naught was nothing but 1 upon under root LC, and if I fill the value of L effective, I'll get this answer, which is option number C.